Hi, good morning, everybody. Welcome to my project. My name is UNNI. I'm located in Singapore and working for the Singapore government in the Building and Construction Authority. My project is starting with a problem in advertisements in the newspapers and magazines. We have this expensive advertisement with the logo of the company, but it is not used as a means of communication. Instead, the company uses the company URL or Instagram or Facebook as a means of getting a lead from the reader. So I want to change the scenario by introducing a computer solution to scan these logos and get as a means of communicating. Thank you very much, and let us look into the problem, how it is getting solved. So in this project, we have designed a set of neural networks and compared and contrast its operation. We have a fully connected neural network and a convolutional neural network. I compared the performance of the two and we are presenting the results. So let us take, for example, a real life example problem of Stanford. Okay, you can encode www.stanford.edu as a barcode or as a QR code, or in this project we can actually scan the logo and get to the desired URL. That is the solution that we are bringing in. So let us start with the data used for the experiment. In this case, we have downloaded 6 different of company logos, and using a program, I reformatted the file size to 64 by 64 into 3 colors and organized in starting with a number representing the 0 to 5, followed by the company name and the serial number of the file name. So this way it is very easy for the program to read these data files. Now, when an image is given to an edge device, it could be a barcode, it could be a QR code, or it could be running a full deep convolutional neural network. So the time taken depends on the type of image that is coming. If we have 3 different programs, so in this case I use a signal called strobe signal to shut down the processors once CPU 1 completes its task, or if CPU 1 fails, then the shutdown using the strobe signal will take place when the QR code application CPU 2 is complete. If CPU 1 and CPU 2 cannot do the job, then the GPU deep CNN will run into its completion, taking the longest period. Now that the data is ready, let us develop a model. In this model, the first attempts, I created a fully connected neural network with 3 hidden layers and a softmax as the output. This was tested using image sizes of 64 by 64, and the dataset had got 200 images of each type. This is a very small set. We can increase the quality of the output or the performance of the network if we had trained with a larger number of images as data. So in this second model, I use a convolutional neural network with a 3 by 3 convolution followed by a batch norm, followed by a ReLU, followed by a 2 by 2 max pool and a softmax. Here I did an experiment The original network has only 6 images, A, B, C, D, E, F, which is representing A for Apple, B for BMW, etc. But I tried to increase this number of vector size to a million and 10 million, and it could compile and give no error. That means this model may be possible to expand to a very large set of inputs. However, with the time restrictions, I have completed it only with 6 sets of data. Thank you. So here are the results for the comparison between the fully connected neural network and the convolutional neural network. Obviously, the accuracy of the training as well as test is higher in the convolutional network. Please note that we can further enhance the accuracy if we had started with larger number of data sets. Now, let me highlight one more time on the expandability of this project. On the softmax output side, I tried with an experiment of defining 100 million labels by putting the vector size to 100 million and put a value of 999, the last row of the vector, and it worked. And it took less than a second to pass through the softmax stage. So I hereby prove that the model that we have designed is capable of expanding to a large number of logos, a few millions for sure. Now that we have a working model, we can now create an app on phone or a IoT device. Thank you very much. A zillion thanks to my project supervisor, Mr. Steven Chen, who guided me very well. And my feedback is that CS230 Deep Learning team did a very good job. Keep it up. Hooray. Thank you.